uploaded homework number 1. Okay, so if you look at over here, I've uploaded homework like what we had before for 3A and for 2Q is the same. But now something different. Okay, I'll show you what is the different now. Okay, so if you were to download, this is the homework. Okay, so let me get you a different view if I could. So this is your homework that you see. Okay. All my homework, you have to answer 5 questions. Okay. This is a bad example over here. Anything that you see a number over here, you have to do. Okay. And what I've done this year, like over here, this is a different question, but I put it as what? Example. Are we clear? So the example means this is the question, the solution is also provided already. Okay. This you also do, but you don't need to hand it. What? Confidence. Yeah, I want to give you some confidence. The solution is provided. Okay, so for this question, okay, you do on your own. If you don't hand in, I'm fine. Okay, so for the next one, you see question 2, solution not provided, but the final answer is provided. Question number 3, question number 4. Then you see the next question is again and what? Example, the solution is provided. But that does not mean that a solution provided. No. Then these examples can be the question. The only thing is you don't need to work and then in. Are we clear? Okay, so because the last course evaluation that I got, not enough examples. Okay, so I'm giving you all more examples now. So only do those questions that have what? That has number on the side over here. Are we clear? Okay, only do those questions that have number, more exposed, more questions. Okay. The due date. I usually give a week due date is due on January 20th. And if can hang in up to 5 days late, say your MSAT. Okay, I don't, you're wasting your time on MSAT. Okay. You can hand in up to 5 days later, but half the months will go. We clear. Okay, so same like 2Q04. Okay. Now 5 questions is not a lot. Am I right or am I wrong? Okay, it's not a lot. Try to finish them. Be ahead of time. Okay. All right. Before I go on, please go into week 2. Download the examples that I'm going to do because all the images are going and questions are going to be taken from there. Okay. So today we are going to focus on the extension of Euler's formula. Okay, we're going to focus on the extension. So based on Euler's formula, okay, for buckling, there are 2 formulas that you have seen before. One is based on the critical load, which is equal to pi squared EI over L squared. And the other one is based on critical stress, which is based on critical load divided by cross-sectional area. And this eventually will become pi squared EI or EI over A. There's an L squared missing on my term over here. I do apologize. Oh no, there's no L squared over here. But there's an L squared over here. And then when we write this out, it can be also E squared E over L over R squared. Okay. So as you already know, L over R is known as the slenderness ratio. Okay. Now, also known is that the resistance of buckling is dependent on, okay, Young's modulus, as you can see. So this is our E. Is that dependent on the length? This is our L. It's also dependent on our cross-sectional area or cross-sectional geometry, which will affect both our I and cross-sectional area, and also how the structure is held on its end. So to write this out based on the extension of Euler's formula, you write this out as ECR is equal to pi squared EI over LE. S is equal to pi squared E over LE over R squared, where LE is known as the equivalent length, and is dependent on how the ends are fixed or are held. If I say fixed, it's pretty contradicting. So based on yesterday's notes, we have this image, okay? So I want you to pick this image out. Okay, if you have this image, download this image as soon as possible. Now, these images, initially, when you look at them, it's pretty confusing. Okay? Initially, when I look at them, I find it a bit confusing also, okay? So the most important thing to observe is the deformation pattern. Okay, observe the deformation pattern. Okay, when I look at them, you know, you have this mode, it's like, see nothing. Okay, that was me. Okay, but don't be like me. Okay, I just like, okay, it's a diagram, move on. Okay, the deformation pattern is as critical over here as anything else. Okay, so the first one is one end is fixed and the other end is free. Okay, so you can see, right, this is how the deformation pattern looks like. So if when it's fixed, right, what you can observe is over here is more like zero bending, then on top here, then it start to bend. Okay, so this portion over here is like a straight line. Okay, and the next one, both ends are pinned. So let's focus on the deformation. So you can see that theta is not equal to 0. Okay, theta is not equal to 0. So theta is the slope of deflection. Okay, so over here, theta is also theta is equal to 0 when it's fixed. Now the next one is a combination of one end fixed and one end is pinned. Okay, so what you observe over here, you have a what? You have a radius, you have a curvature, you have a theta. But once you come over here, theta is equal to what? 0 again. Over here, theta is not equal to 0. And you look at the observation pattern again at A when both ends are fixed, and then at point B, right? It comes out again. Over here, the slope is equal to 0. Slope is equal to 0. Okay, so observe the slope. So I want you to make that observation. Okay. So another thing that I want you to highlight, how to recognize what is what. Okay. So whenever, if it's fixed, right, M is not equal to 0. The moment is not equal to 0. Okay. So for the first one, the other end is known as free. When it's free, the moment is equal to what? 0. Okay. The next one on the center, when both ends are pinned. Okay, so for this case, theta is not equal to 0. When that's the case, moment is equal to 0. Over here, moment is also equal to 0. The next one at point A, the slope is not equal to 0. So moment is equal to 0. When theta is equal to 0, moment is not equal to 0. Okay. So the theta and the moment behave like a father and daughter relationship. When I tell my daughter, don't go there, what will she do? She will do it. Okay? Teaching you guys are easier than teaching my daughter, okay? And some of you will say, Eugene, you deserve it. Are we clear? Okay, so this is how you recognize your now the difference, when is it a free? Okay, when is it a free? Okay, so now I'm going to sketch a green line, which is a centroid. So the green line is my centroid. So you can see the P shift away from the what? Right? So when the P shift away from the centroid, this is where we call it as what? Free. The next two cases, as you can see for yourself, okay, the P is aligned to the what? To the centroid. Can you see that? Okay, the P is aligned to the centroid. So the only case where it's free is when the P